So this is the second video on differentiation from first principle. So let's say we are given y is equal to x to the power of 4, and we are asked to differentiate this using the first principle approach. So remember, in the first video we said you add change in y to y. That means you also add change in x to x. So that means in place of y we have y plus change in y, and this is going to be equal to, in place of x we have x plus change in x. But since s here is to the power of 4, that means you're going to be having this to the power of 4. Now, to expand this, we simply employ the Pascal's triangle. Now, what are the values of the Pascal triangle for the fourth power? Let's just do a rough sketch somewhere here. Remember how it starts: 1, 1, 1. You have 1, 2, 1. You have 1, 3, 3, 1. Then you have 1, 4, 6, 4, 1. So this becomes the Pascal triangle for the fourth power, right? So we're simply making use of 1, 4, 6, 4, 1. So which means we're going to be expanding x plus change in x to the power of 4 using 1, 4, 6, 4, 1. Okay, so let's do that together here. So I have y plus change in y to now be equal to, in place of x plus change in x to the power of 4, we expand using 1, 4, 6, 4, 1. So that is 1 multiplied by x to the power of 4 multiplied by change in x to the power of 0. So x usually starts from 4, change in x starts from 0 and climbs to the power of 4, whereas s starts from 4 and reduces towards 0. Okay, then we have plus, next value there is 4, so we have 4 multiplied again by x, so x now drops to the power of what? 3, multiplied by change in x now increases by 1. Okay, plus next value there is 6, so I have 6 times x again drops to the power of, now is going to be 2 times change in x again increases by 1, so you have change in x to the power of 2 plus next value there is 4 into x drops again to 1 by 1, so it becomes x to the power of 1 times change in x once more increases by 1, so change in x to the power of 3, and finally plus 1 times x drops again by 1, that is to the power of 0, times change in x to the power of 4. Okay, so this means y plus change in y is going to now be equal to x to the power of 4 times 1 times change in x to the power of 0 remains x to the power of 4 plus, now I have here 4x cubed, 4x to the power of 3, change in x to the power of 1 remains change in x, plus 6x squared, so I have 6x squared, change in x to the power of 2 remains change in x squared, plus I have 4x change in x to the power of 3, plus this becomes change in x to the power of 4. Okay, so at this point what we'll do is simply what? Transfer y. We simply send y to this side of the equation. Since we're looking for the y over the x, let's now make change in y subject of the formula. So we're going to be having change in y to be equal to, this is x to the power of 4 plus 4x to the power of 3 times change in x plus 6x squared change in x squared plus 4x change in x to the power of 3 plus change in x to the power of 4. Now if y comes over here, y becomes negative, so I have minus y. Okay, now you recall from the question we said y is equal to what? X to the power of 4. So just to make everything on this side of the equation to be in unison of x, I'm going to be replacing y here by what? X to the power of 4. So if we do that, our equation becomes change in y equal to x to the power of 4
plus I have 4x to the power of 3 times change in x, plus I have 6x squared change in x squared, plus I have 4x, okay, I have 4x change in x to the power of 3 plus change in x to the power of 4 minus y. In place of y is simply x to the power of 4. So you observe now that I have here x to the power of 4 minus x to the power of 4. So these two will easily cancel out. So these two will easily cancel out. So if we do that, we are going to be having change in y to now be equal to, so I have 4x to the power of 3 times change in x, plus I have 6x squared change in x squared, plus 6x change in x to the power of 3 plus change in x to the power of 4. So at this point, all we simply do is, since we're looking for the y over the x, we divide both sides by change in x, right? If we do that, we are going to have change in y all over change in x to be equal to 4x to the power of 3 change in x divided by change in x, plus 6x squared change in x squared all over change in x, plus 6x change in x to the power of 3 divides change in x, plus change in x to the power of 4 divides change in x. And if we do this, we'll have change in y all over change in x to now be equal to, over here change in x cancels change in x here, so we have 4x to the power of 3 plus change in x cancels one of the change in x here. This gives us 6x squared change in x, plus similarly change in x here cancels one of the change in x here. We have 6x change in x squared, plus over here one change in x cancels one from here. We are left with change in x to the power of 3. Now when we arrive at this point where we found change in y over change in x, but we still have a mixture of change in x in the expression, we simply employ or apply our limits. So the rule states that the limit as change in x approaches 0, the term change in y all over change in x automatically becomes dy all over the x. So this simply means that if I spot change in x in the expression after I've obtained change in y over change in x, simply put the value as 0, and if that happens, then change in y over change in x becomes dy all over the x. Therefore, dy over the x is now going to be equal to, I have 4x to the power of 3 plus 6x squared times change in x, but change in x now is 0, plus 6x change in x squared, so you have 6x times also change in x is 0 all squared, plus change in x cube, change in x itself is also 0 all cube. Okay, so this simply implies dy all over the x is going to be equal to 4x to the power of 3, because you know that 6x squared times 0 is 0, 6x times 0 is also 0, and of course 0 to the power of 3 is also 0, so I'm left with 4x cubed, and that becomes the answer to that question. So let's confirm this using the power rule. Recall, if y is equal to x to the power of 4 from the power rule, it means that dy all over the x is equal to, use the power 4 to multiply the variable x, then subtract 1 from the power power is 4, so you have 4 minus 1. So this is actually going to be 4x to the power of 4 minus 1 is 3, and that becomes the same answer as what we obtained earlier. So that's it on how to differentiate from first principle when given functions. In the next video, we are going to be looking at derivative of trigonometric functions from first principles. I'm sure you want to be a part of that video, so do well to hit the subscribe button right now and turn on your notification bell so you don't miss out on that video when it drops. In the meantime, do well to like this video, share to your friends, comment nicely, and I will see you in the next video. Cheers.